This is actually one of the longer lessons in the entire live lesson series for CASP. And in 5.1, I'm going to do one of my demonstrations again. This is physical and virtual network and security devices. So we'll talk first about secure switches, secure routers, and firewalls. Then I'll give you a demonstration of a zone-based policy firewall on a Cisco IOS router. We want to start with switches, and switches are layer 2 devices, and they're going to provide a ton of security features. It's part of a trend now to add more switch security to kind of move the security down closer to the endpoint. So switch security and endpoint security is a huge trend. Security switches have a variety of services to secure frames to and from endpoints, as well as between switches. One of the advanced features is IEEE 802.1x port-based network access control, or PNAC, which basically allows us to use the EAPOL protocol initially to connect to a switch and then add other layers of security on top of that, extensible security, things like EAP TLS, protected EAP, and others. If we're using .1x, we can also use 802.1ae MACsec, which actually allows us to encrypt the frames with AES GCM, going from the endpoints to the switches, but also to encrypt the frames going between switches in our switch fabric. We can also get integrity and authentication with a SHA-2 HMAC. Security switches also can create snooping databases. So for example, if you're using DHCP on your access layer switches, you can turn on a DHCP snooping feature, and then for your corporate VLAN, you can make those ports untrusted so they cannot send DHCP server transmission. So DHCP snooping builds a database that maps the IP address to the MAC address to the VLAN to the physical interface, and you can use that database to provide dynamic ARP inspection, to prevent ARP spoofing, ARP cache poisoning attacks, misuse of gratuitous ARPs. We can also use the snooping database to apply port-based ACLs to our switch ports, even getting protection for IP version 4 and IP version 6 traffic by using the database to make sure that IP traffic adheres to the mapping in the database between IP addresses and valid MAC addresses. And of course, for statically assigned ports that aren't using DHCP, you have several workarounds that you can use as well. Also, switches can do ether type ACLs, where they can make decisions based on the ether type value in the Ethernet frame header. For example, making decisions on MPLS and BPDUs. Security routers are very common. The Cisco IOS is a security router. The Juniper router also has security features. Really, all routers do today. They're primarily layer 3 devices, but they can also function at layer 2 in a bridged or transparent mode, and they have the ability to do inspection at layer 3 and 4, and layer 5-7 inspection, which is called Deep Packet Inspection, DPI, or fine or granular control, or sometimes it's called Application Visibility and Control. Of course, routers are going to separate our broadcast domains with VLANs, and that does add some level of security, but we also have to make sure that we implement some features on the switches and the routers to prevent VLAN hopping. Routers can use static routing, or they can use dynamic routing protocols like RIP version 2, OSPF, EIGRP, BGP, and others. Some of the security services that we would see on a router, and they can be modular components that you put on the router, or they can be actually integrated into the operating system itself, is firewall services, intrusion detection, intrusion prevention services. They can be VPN gateways or VPN concentrators. They do network address translation and port address translation. They can perform URL filtering either locally or to a third-party vendor like WebSense, for example. They can provide proxy services like encryption and decryption services. They can also inspect traffic all the way from layer 2 up to layer 7. Firewalls come in all types of flavors, and really a firewall is a metaphor for just some type of system that prevents a fire from spreading from one zone to another. Okay, so here we see in the diagram the classic 3-legged or 3-armed firewall, where the internet is our public zone or our internet zone. We have a DMZ network where we put our public-facing servers, and then of course we have our internal network. Firewalls can be stateless or stateful. If they're stateless, they'll just look at one packet at a time and apply some type of access control list or access control rule to that packet. If it's stateful, it's going to maintain a state table and a connection and or host table to look at the entire TCP connection from start to finish and UDP flows. And you can also statefully inspect ICMP and IPsec ESP. A firewall can be restrictive or permissive. If it's restrictive, it'll deny all traffic from all the zones by default unless you explicitly whitelist the traffic. If it's permissive, like an IPS, it will allow the traffic unless there's some match of a signature or some rule. Firewalls are also application layer gateways, performing application inspection or application visibility and control and deep packet inspection from layer 2 up to layer 7. They provide proxy services. And of course, it's all about next generation firewalls now. The Cisco 5500X and their firepower, the Palo Alto Networks firewall is next generation, and it really means advanced malware protection using cloud services, as well as context-aware access control based on the user in some type of database like Active Directory or eDirectory, and having the ability to do content inspection going beyond just the port. Okay, the port numbers, but actually looking at the characteristics and the behavior of the application. That's what the modern firewalls are doing today. What I want to do now is show you a demonstration of configuring a zone-based policy firewall on a Cisco ISR Generation 2 router. We're going to look at security zones here, DMZs, separation of critical assets, and network segmentation with a zone-based policy firewall from Cisco. Here at the center is our Integrated Services Router Generation 2. It's a 3-armed firewall, and we're going to set up our zone-based firewall here. We're going to provide access between 3 zones, the inside zone. We have an outside public zone and a DMZ zone off of 3 interfaces. We're going to allow HTTP, FTP, and ICMP to the DMZ from both the inside and from the outside. General TCP applications, including inspecting FTP for dynamic negotiated connections, and ICMP will be allowed from the inside zone to the outside or untrusted zone. There'll be no policy defined to allow traffic to initiate from the outside to go to the inside. Also, no policy is going to be defined that will use the DMZ as the source zone. So our sessions will not originate from the DMZ to anywhere. Let's jump over to our router. We're in global configuration mode here, and we're going to define a security zone named inside. So zone security in all caps. It's user defined inside. We'll describe this. The description is trusted internal networks. Let's get onto the interface that's part of this zone. Interface gigabit 01. And you're a zone member, followed by the correctly spelled security keyword. Got to do that correctly. Security inside and then exit. Now let's create a zone with the security keyword called DMZ. We'll describe this as the demilitarized zone services available to internet. Let's go to interface gigabit 02 now. We're going to say you're a zone member with the security keyword of the DMZ. Exit out of there. We'll do our third zone, which is zone outside. So inside DMZ and outside zones, we'll describe this as untrusted internet, and then we'll go apply this to gigabit 03, interface gigabit 03, fat fingering a lot here. You're a zone member of the outside. Let's do a show command now to verify our assignment. We'll do show zone security. Here's our inside zone on gigabit 01, our DMZ on gigabit 02 and outside on gigabit 03 in our descriptions. Now let's make sure there's no policies configured between these zones on the zone pairs. We don't really have any zone pairs, so we should just see nothing here. Shows zone pair security, nada. Now by default, the zone-based policy firewall will deny all traffic between security zones unless you explicitly permit it or allow the traffic or whitelist it. So at this point, there should be no traffic crossing this router because we have no interfaces that have zone pairs and policies. So to verify this, let's go to the admin PC and try to ping either the DMZ server and or the outside server. Let's give it a shot here. So we'll first try to ping the DMZ server at 172.16.1.50. That didn't work, so Control C. Let's try to ping the outside server at 192.168.1.50. No go. We can't get through this router right now. It is a restrictive router or restrictive firewall. Now there is an IP address assigned to the router that's associated with the system-defined security zone. This is called the self zone for management purposes. It's really the control plane and the management plane of this router. Anything that gets punted to the processor. So packets that are destined to this router or coming from this router will be actually implicitly permitted because of the self zone policy. Now, let's go ahead and define policies for access to the DMZ. So, we're going to use a class map to do this, which is a class map of type inspect. So in global config mode, create a class map. We are identify or classify traffic, and it's of type inspect. And we're going to go ahead and do a match any. Let's just do a question mark and take a look. Notice we have match all or match any. Match any is a Boolean or, okay? Match all is a Boolean and. Anytime you see a class map that has a keyword of match all, that should be a red flag for troubleshooting because everything that follows this has to match, okay? If there's anything mutually exclusive, then basically match all will break it. Now we're going to do the Boolean or match any. And we're going to call this inspect, this class map DMZ services. And we're going to match some things. Now we could use a classification ACL, an access control list or an access control rule, and we could have already created this classification ACL where the permit means it's interesting. We want to take action on what we're permitting. But we're going to go ahead and just match a protocol here. So let's say do a question mark. We can do match an access group. We can match an existing class map if we've already created one. Okay. We're going to do protocol. PAM stands for port address mapping. So we're going to match protocol FTP and match protocol HTTP and match protocol ICMP. And again, good thing we're doing match any, because if we did match all, this would be a problem because there would be no one packet flow that's going to match all three of those protocols at the same time. So they're mutually exclusive. So we got to use match any. So let's exit out of here. Now we could use an access control list and combined with a class map or a protocol. So we could have several things matching here. Let's go ahead and create an access list. IP access list extended. Let's call this DMZ servers. Now the interesting traffic we're going to permit is IP traffic from any to host 172.16.1.50 and then exit out of there. Let's create another class map, and let's say class map of type inspect, and we're going to match all. Okay, the Boolean and we're going to call this permitted DMZ sessions. Now let's match another class map, the one we created up here, DMZ services. So let's match that class map, which is FTP. Got to fix that, hold on. So we're going to match that class map, and we're going to match the access list. Access group, name, that's a weird keyword we got to have there, name. And the name of the ACL is DMZ servers. So here we're going to match the class map DMZ services and the match the ACL DMZ servers. Now let's determine the action we're going to take. Okay, so we're going to do this with a policy map, and it's a policy map of type inspect, and let's name it DMZ access policy. Okay, there's our policy map. So now we need to nest the class map or reference the classification, and we're going to reference the class type inspect, and we'll just use permitted DMZ sessions. Now, in our policy map, we've identified our traffic using a class map. We've nested it, we've referenced it, but now what action are we going to take? So we'll do a question mark. We can inspect the traffic, layer 3-4 inspection, which allows us to do layer 5-7, advanced visibility and control. We could pass the traffic along, or we could drop it. We're going to drop it. We also have policing, which is, some quality of service, but we're going to go ahead and inspect it. Statefully inspecting at layer 3-4. And of course, if you inspect statefully at layer 3-4, the metadata of the ICMP and TCP UDP, if we want to further inspect it at layer 5-7 or AVC, if we want to do that, we have to inspect it at layer 3-4. So we would basically create an inspect map or a layer 5-7 policy, and we would kind of follow this inspect command with the name of that policy. Let's do a show real quick. Show policy map of type inspect. So we have the DMZ access policy referencing the class permitted DMZ sessions, and our action is to inspect. So now we have this reusable construct, this component. We also have interfaces assigned to zones as zone members, but we need zone pairs. The zone pairs is going to identify the unidirectional traffic, okay, what we're going to whitelist from one zone to another. The service policy is the third component of this security policy. And this actually gets applied to the zone pair, not a physical interface or a logical interface. So we need to create our zone pair. So we're going to do zone-pair, type security. We're going to call this outside to DMZ. So we're naming it something intuitive. And the source of the traffic, as you can tell from the name of the zone pair, is outside. We're using all caps. And the destination is the DMZ. So there's our zone pair. So now we'll use the service policy command, and we're going to say it's of type inspect again. So we're going to apply DMZ access policy and exit out of there. Now, because these are reusable objects, we might want to have a policy for traffic going from the inside to the DMZ. And the good news is we've already got a reusable object, so we could apply that to that traffic. So let's create a zone pair, another zone pair with security, and it's going to be inside to DMZ. The source of the traffic is the inside zone. The destination of the traffic is the DMZ. And we're also going to use the service policy of type inspect. And see here we could use inside host to manage those DMZ servers or upload content to those DMZ servers, based on those three protocols. Okay, let's do a show zone pair security, and there's our outside to DMZ zone pair. We can see it's from the outside of the DMZ, and there's our service policy applied. That invokes that policy map. Here's our inside to DMZ, source to destination, and again we're applying DMZ access policy, the same policy. Let's make sure we can allow ICMP traffic, FTP traffic, and HTTP traffic from the inside to the DMZ. So let's do some testing here. We're going to go to the admin PC on the inside, and we're going to do a couple of things on those DMZ servers. First of all, let's see if we can ping the DMZ server at 172.16.1.50. And we can. That's good news. There's our 4 Microsoft Echo replies. Let's see if we can FTP to 172.16.1.50, log in as anonymous, and then, all right, message 230, login successful, 221, goodbye. Let's go to Firefox and see if we can browse the DMZ server, so HTTP, so 172.16.1.50, and there's our DMZ server web page. And you can see we're accessing it from 10.1.1.10, the admin PC. Now, we know what's allowed to the DMZ server, but what's not allowed? Well, everything else pretty much, okay? Remember, we only matched those 3 protocols and to that one IP address. So we shouldn't be able to telnet. So let's try that. Telnet 172.16.1.50, and we cannot telnet, okay? And we can watch this all day, ain't gonna happen. Also, we could use HTTP, but we can't use SSL TLS. So we do HTTPS with that IP address. That should be a no-go. Should be a non-starter. Yeah, no luck. Okay, so we've established our policy using our zone-based policy firewall to the DMZ server at this IP address .50. Let's go ahead and define and verify an inside to outside policy now. So we'll do some of the same types of steps. We're going to go to our zone-based router, and in global configuration mode, we'll create a class map of type inspect, and we're going to do a match any, and let's say it's going to be called inside to outside typing protocols. Typing issues today. We're going to match protocol FTP, and then do an arrow up, and we'll match protocol TCP, and then we'll arrow up and match protocol ICMP, and then we'll exit out of there. What's interesting here is there's no HTTP. We'll do a policy map of type inspect, and we'll call this inside to outside policy. I gotta fix this, sorry. Inside to outside, I want dashes, not underscores. And let's go ahead and use our class map that we created. Class type inspect. Look out for that underscore. This is good troubleshooting practice. It's got to match exactly, so I need to make sure I have that goofy underscore there. Inside to underscore outside protocols. So what's the action we're going to take? Well, we're going to inspect the traffic. Having a hard time typing. All right, we need a zone pair. So zone pair security keyword, and we call this zone pair inside to outside. No underscores. The source of the traffic is inside, and the destination of the traffic is the outside. We're going to apply a policy with the service policy command. That's what activates this. It's of type inspect, and we're going to use the policy inside to outside policy, and then exit out of there. Okay, so let's do some verification, proof of concept that we have ICMP, FTP, and general TCP whitelisted from the inside to the outside. So let's go back to that admin PC and let's ping the outside server 192.1state.1.50, and there's our successful replies. Let's FTP to that outside server from this inside host at 1.50, anonymous, and login successful. Bye. And how about browsing? Let's go back to Mozilla. Now we didn't say HTTP, but we did say TCP. And of course, HTTP is a TCP based protocol. So let's try to get to that outside server at 1.50 using HTTP. And there we go. You can see we're on the outside server. Now, what about HTTPS? 192.168.1.50. Oh, we got there, but it's allowed. But we're going to get our browser warning message because we don't trust the certificate. And you don't want to see these in the real world, of course. And this is an area we'll talk about in other areas of this live lessons training. But we did get through the firewall here. Let's try to telnet, which is also going to use TCP. And we're waiting for a response from the server, but we should be able to, there we go. Let's go ahead and authenticate as guest with the password guest. There we go. On the Kali server, we're going to log out. Now remember, we don't have a policy configured for the outside zone to the inside zone, and that's actually a best practice. But if we try to do anything on the outside to create a flow to the inside, so anything should be dropped. Let's verify that. Let's go to the outside PC right there, 1.10. And let's see if we can get through that zone-based firewall. Remember, there's no zone pair going outside to inside, so we'll just do a ping. We could do we could try all those different protocols that we've been using, but let's just do a basic connectivity test with ping. Let's try the inside server at 10.1.1.50, and that's not going to work. How about the inside admin PC at 1.10? That's not going to work either. As a matter of fact, anything we try to do through that firewall from the outside zone to the inside zone will be denied. Excellent. I hope you enjoyed this demonstration.